Okay, good morning. Welcome to
MathPractice138.
Yay! Low five. Okay, today we're going to talk about a neat formula. We've been talking about perfect squares, right? And now we're going to talk about numbers that differ by 2. We're following Beast Academy, which does a great job with this, and I thought we'd do a video about it just to talk about it, okay?
Yeah.
So we know this. We know 2 times 0 is
0.
3 times 1 is
3.
4 times 2 is
8.
5 times 3 is
15.
6 times 4 is
24.
7 times 5 is
35.
8 times 6 is
48.
And there's an interesting pattern with these numbers. What is it?
Well, they're one away from a perfect square.
They're all one away from a perfect square. This is interesting. This is 1 squared minus 1. This is 2 squared minus 1, because 2 squared is
just 4.
and 4 minus 1 is
3.
This is 3 squared minus 1. This is 4 squared minus 1. 5 squared minus 1, because 5 squared is
25.
25 minus 1 is
24.
6 squared minus 1, and 7 squared minus 1. What's 7 squared?
Is 49.
49. 49 minus 1 is
48.
So it's a really neat pattern. We keep increasing these numbers by 1 in each column. So our next one would be what?
That would be 10 times, no. We have 9 times 7.
What is 9 times 7?
63.
63. And what is 8 squared?
64.
That's 1. So the pattern seems to keep going, and we're trying to wonder, why is this true? So I thought we'd do a little video showing it. Right? Now, which one of these do you want to do with our Duplo blocks to show why this works? 5 times 3?
Yeah.
Okay. So I got to rotate this. So 5 times 3 is what?
Is 15.
Okay, 15. Would you mind making a 4x4 square out of those red blocks? And I'll make three 5s out of this. Do we have enough to make a 4x4 square?
I think so.
Okay, great. We've got our handy dandy Duplo blocks, and we're going to try to show y is 5 times 3, 4 squared minus 1. I don't have enough green blocks. I have to do almost green blocks. Okay, so I have 5 times 3 here, right? 1, 2, 3, 4, 5, 3. 5 times 3, or 3 times 5, however you want to think about it. And here we have 4 times 4. Okay? Now, can you take away 1 block from the 4 times 4? Because we're trying to make this be 4 squared minus 1. Okay, so there's 4 squared minus 1. Now, how many blocks are here now?
There are 15.
15, because there used to be 16. Show your block that you stole. Aha! There were 16, and now there's
15.
Okay, now we're going to see if we can try to transform this shape here, this rectangle, 5 by 3, into this shape. Is there any way we can do that?
You can do that.
Aha! How interesting. We just take one row at the top or at the bottom, depending on which way you're looking at it. But does it matter if it's the top or the bottom?
No.
No. And you just slide it over and make it vertical instead of horizontal. And look at that, you have exactly the same shape. And this tells us, in this case, this tells us that 3 times 5 is 4 squared minus 1. And the exact same thing, and maybe you can do this with some other numbers today, just to play with it, play with the blocks.
Yep.
Here we have n equals 4, n squared minus 1, well, n minus 1 times n plus 1. So if you take any number, you take one less than it, one more than it, and you multiply them together, you get that number squared minus 1. So what do you want to pick for n for our last example?
How about 7?
7, okay. So let's see. 7 squared minus 1. What's 7 minus 1?
Is 6.
What's 7 plus 1?
Is 8.
What's 6 times 8?
Is 48.
Is that 7 squared minus 1?
Yes.
All right. That's a neat geometry, neat numbers, and then later on, we'll learn some cool algebra.
Yep.
Good job. Good job, sweetie pie.